In this impossible shot, we are going to create land sharks. Not only that, but we're going to show you how to do it using your footage and free software. Specifically, we'll track in Mushroom, animate in Blender, and composite in Nuke non-commercial, all free downloads. Now I should mention that there's a whole lot of room to take this shot further. It needs debris dust, and probably a better looking shark, but those are all things you can add to finesse your own version of the shot. As for the current shark and the cracking road, you can download those from the link provided in the video description. Alright, let's dive in. Firstly, let's talk about shooting the footage. The most important thing is that you have a flat stretch of ground for the shark to traverse. You can choose the direction the shark moves. The important thing is that it has enough runway in the final shot. Here, we shot footage with an iPhone on a basic stabilizer rig. Now, normally we tell you to use a fisheye camera with multi-exposure capabilities to capture an HDR light probe of the set. But in a pinch, you can just use standard phone panoramas. And that's the workflow we're going to show here. We'll simply shoot a panorama of the surrounding area that would have illuminated the cracked road and the shark had they really been there in the shot. Since the iPhone won't shoot a full 360-degree panorama, we'll shoot a second one to fill in the missing section. And finally, we'll shoot the sky directly above, which will obviously be the main source of light for the scene. All very unscientific, but it should be enough to get our scene lighting in the ballpark. With the footage and helper images in the can, let's head into post to build this thing. First up, camera tracking the scene. We'll do this step using the amazing and free Mushroom. Watch our Mushroom survival guide to check out the full process, including how to inject your camera focal length into the footage metadata. The important steps at the end are adding an export animated camera node and making sure it exports an undistorted copy of the footage. And creating a single UV texture map by setting texturing to LSCM and disabling UDIM. You can also tell it to fill holes in the texture if you like. As always, Mushroom processing time depends heavily on your CPU and GPU power, so be prepared to wait a while. With the tracking done, it's time to start assembling the scene in Blender. If you're new to Blender, watch our 30-minute survival guide to catch you up on the basics. First, import the camera track from Mushroom. It's stored as an Alembic file, so we'll choose File, Import, Alembic, find the camera.abc file and import it. Now we'll grab the actual scene scan which Mushroom created as an OBJ, and so we'll choose File, Import, Wavefront OBJ. We can't see the texture on the scan yet, so change the viewport shading mode to Material Preview using this button. While we're at it, let's delete the annoying default cube Blender puts into every new scene, and rename the scene scan to make more sense. Now we want to be able to line up our camera and scan scene with the shark simulation. So let's add an empty, Blender speak for a null or locator, and parent the camera and the scan mesh to that empty. Choose Add, Empty, Plane Axes Empty. In the outliner, we'll rename it to Orient Null. Now we simply select the scene scan object and the camera, called MVG Root, and then select our new Orient Null. Right-click in the viewport and choose Parent, Object to parent the camera and scan ground to the Orient Null. Now if we select the Orient Null and move or rotate it, both the camera and the scanned ground move together. Now let's bring in the simulated ground shatter you downloaded from Moviola.com. It's also an Alembic file, so we'll choose Import Alembic again. For now, we'll work exclusively with the Earth being cracked by the shark. We'll get to the shark in a bit. Let's jump to around frame 40 where the simulation really starts to kick off. We need to reorient our viewer so that the Earth is pushing upwards as it breaks apart. Simulated geometry can be pretty heavy and slow to manipulate, so rather than trying to move the ground simulation in place, we'll move the camera and scene scan by selecting our Orient Null. Choose View, Area, toggle Quad View to help with lining things up. In my case, I need to rotate the scan and camera nearly 180 degrees to line up with the simulation ground. One trick for getting precise rotation adjustments is to drag out the rotation handle like a long lever. Now I'll move the null or empty so that my scanned road lines up with where I want the broken earth action to take place. In my case, the scale works out pretty well. You may need to scale the orient null so that the size of the shark and broken earth makes sense for your scene scale. Time to look through the camera. If I click the camera icon in the viewer, I get the default Blender camera. I need to drill down and find the actual scene camera created in Meshroom. Okay, now I'll step through a few frames of the simulation to see how things line up. Overall, pretty good. Finally, I need to make sure the ground level of the Meshroom scan lines up flush with the top of our simulated ground. I'll rotate a little to make sure I get a fairly even alignment across the road. Let's add the shark. Because we chose to scale the camera and scan scene rather than the ground, the shark animation should drop in without any adjustments required. Now that all our basic elements are in, let's tackle lighting. If you remember, we just have a couple of panoramas and a shot of the sky. So we'll set up a cylinder for the main wrap panorama and a plane for the sky above. I'll start by adding a cylinder. I'll rename it Main Translight, since that's basically what it's going to be in our scene, an illuminated background image. Now I need to scale it up to make it big enough to cover the boundaries of the scene. We only need the sides of the cylinder, so let's pop it in the Modeling tab, make sure we're in Edit mode and selecting Faces. Select the top face, press the Delete key, and repeat for the bottom face. Alright, back in Layout, we'll switch to the Material tab, and with the Translight cylinder selected, I'll click to create a new material. To see the material's node network, switch to the Shading tab. Now, if you don't like nodes, don't panic. Most of the time these days, building materials is just a matter of plugging an item or two into the master shader, called the principled shader. I'll click in the node view, press the tab key, and type Image in the tool picker to add an image texture node. Then I'll go looking for the panoramic image we took of our scene with the iPhone. Normally, you wire image textures into the diffuse channel of the material, but we want this to be a light source, so I'm connecting it to the emission input instead. Zooming out, you can see that the cylinder looks washed out. That's because it's adding a generic white on the diffuse channel as well. So I'll go in and set the diffuse channel to black so that the material has no natural diffuse reflective color, only emissive light. While I'm here, I'll also remove any other properties like specularity, since all we want this cylinder to do is project our captured light as a light source for the scene. Next up, the panorama wasn't a full 360-degree photo, but the cylinder stretches that texture all the way around. We need a way to unstretch it a little so there's a gap between the start and end of the photo. I'll add a mapping node and a UV map and wire them up like so. Using the vector inputs on each node. Now I can adjust the X scale to stretch the image out. It'll double up a little to fill the gap, but I'll fix that in a moment. To rotate the image into position, I need to go back to the Cylinders Transform tab and rotate in Z to line it up with our scene scan of the road. Now to fill in the missing bit of our panorama, I'll add a plane, size it, and position it to cover the gap. We also need to bring the cylinder translight up to line up with the ground level more accurately. I'll rename the plane to Translite Filler, and then apply a material in the same way we did for the main translite. And I'll use the other panoramic image we took on the set for this specific purpose. I'll stretch and scale it to match, and then line it up with the cylinder. Finally, we'll add one more plane for the sky image we shot, scaling and positioning it appropriately. In this case, there's no need to rotate or scale the image texture, so we won't add any mapping nodes. Okay, so let's talk materials. We already have a material for the road's surface. It's the live-action asphalt we filmed. We'll actually apply that in Nuke, because it's a little easier to do there than in Blender. In Blender, we'll leave the surface a generic white so that we can multiply it against the live-action texture in Nuke to get all the nice shadow detail Blender is creating. However, when the ground breaks, we obviously didn't film what the sides of the cracked pieces look like, so we need a material to apply to them. Lucky for us, Blender includes a great plugin called Blender Kit for adding materials. It includes paid offerings, but the free ones are surprisingly good. I'll start by clicking to select one of the cracked sides of the broken road. It's been assigned to the inside material, so that's the one we want to make sure is selected. Now choose Edit, Preferences, go to Add-ons and search for Blender Kit. If for some reason you can't find it in your install, you can always Google for it and download it as a separate install. Enable it and you'll immediately see a small search bar appear at the top of the viewport. Select Find Materials and then type a keyword for the material type you want. In this case, that's asphalt. Hover over one of the shader balls for a better preview. And press the arrows to browse through additional choices. When you find one you like, double-click to apply it. Now be patient. In the background, Blender is pulling down the high-resolution texture files from the internet. If your internet connection is slow, that may take a while. If you grow impatient and double-click multiple times, you might end up applying materials to other surfaces by mistake. That looks pretty good. In some cases, you may need to scale the material like we did for the translites, but here the size of the texture looks pretty accurate to real world. It's worth mentioning that we cheated a little. The underside of our road is going to get the same live-action texture as the top. You'd probably want to assign a different texture to the bottom and apply either the asphalt texture or some other earthen texture for more realism in a final production shot. We're going to look at the state of the scene in a moment, but we need to get rid of Blender's default light. Hiding it only hides it in the viewport, not in the final render. So let's delete it to make sure it's not contributing to the scene lighting at all. Now, clicking the camera button to look through the render camera, I can see that I've actually got the scene around the wrong way. My translite is showing the opposite side of the scene. It's a common mistake, so I'll just rotate the translite 180 degrees. Now that puts my translite patch plane on the wrong side, so I'll need to move that over as well. Okay, now, confession time. The shark model is not great. There are lots of amazing models of sharks out on the internet, but for licensing reasons, we couldn't include them as a free download, so I whipped up one on my own in a hurry. One of the reasons I kept the shark dark in the scene is to keep it from the audience gaze, which, by the way, is an old school visual effects trick. If your time or financial budget prevents you from creating full realism in a set piece, find some plausible reason for hiding it. Strong motion blur, heavy shadows, defocus, quick cuts. Why do you think so many monster films happen at night? Anyway, feel free to replace the shark with a better one, or at least improve on the texturing. Here, I'm just going to add the very basic skin texture we've included with the download and leave it at that. One last scene setup before we render. When the ground breaks apart, there needs to be something underneath the ground other than the terror of the endless abyss. So I'll import a lightweight copy of the rectangular prism that I used to create the broken ground simulation. We'll actually be using this for a very specific purpose in Nuke, but for now it serves nicely as a backdrop plane for the exposed underground. Once it's imported, I'll drag it down just below the broken ground . Find a dirt texture, and apply it. We now have a nice fallback texture showing through the cracks rather than a black nothingness. Finally, we made it to render time. Let's pop over to the Scene tab, choose Cycles as the renderer. It's the best choice for production renders. Because our shark uses subdivision surfacing, we need to choose the experimental feature set. Check out our survival guide on Blender for more information. If you have some nice fast graphics cards in your system, you can choose GPU rendering and select the cards in Preferences. I want a high quality render, so I'll increase the render samples to 256. Subdivision settings look good, and I'll enable motion blur. Okay, let's go and enable subdivision surfacing for the shark. Select it, and in the Modifiers tab, add the Subdivision Surface modifier. Now we head to the Scene tab to set up the file output. We'll choose EXR Multilayer, the industry standard for CG renders. If you're tight on drive space, you can choose half float, although for best precision, leave this set to full float. Because we selected Multilayer EXR, we can now choose which layers to render in the View Layer tab. Feel free to enable whatever you like to help with compositing, but for what we're doing, the most important thing is to enable Cryptomatte. Cryptomatte gives us the ability to create custom mattes of any element in Nuke for custom color correction. For flexibility of choice, we'll enable all three Cryptomatte options. Now before final render, we need to hide any elements we don't want the Blender camera to see and render. We only want Blender to render the ground and the shark, not our lighting sources. So for the skylight and the two translate objects, we disable Show in Renders. They'll still be used as light sources, they'll just be invisible to the final render. I also need to disable the scanned ground from Meshroom and disable its visibility to rays so that Blender doesn't compute reflective bounces against it. It was just there for lineup purposes, nothing else. Lastly, we need to set the destination path for our render files and choose Render, Render Animation. Now you might feel that the lighting's a little dim for the scene, and you're right. While we could go in and tweak the intensity of the emission properties, thanks to the floating point rendering we're about to do out of Blender, we can brighten things up in Nuke without any visual loss of detail. We're almost done in Blender and with part 1 of this training. Before we head to Nuke and part 2 though, we need to reformat the camera a little to import correctly into Nuke. The Alembic format stores animation data in a referencing system that won't automatically match a Nuke because of that empty null we parented it to. So here's the fix. 1. Select the camera and duplicate it. 2. Right-click and choose Parent, Clear Parent to set it at the root level of the scene. 3. Delete the Alembic constraint on the copied camera to remove the original animation data. 4. Zero out the translation and rotation data for the copied camera. 5. Go to the Constraints tab and add a Copy Transforms constraint. 6. Click the eyedropper and choose the original camera as the source to copy transforms from. Your copied camera should now follow the original camera precisely. 7. With the copied camera still selected, choose Object, Animation, Bake Action. Enable visual keying, and you shouldn't need to do this since we don't have any, but to be safe, enable clear parents as well. Click OK. At this point, Blender may unceremoniously freeze up. Don't panic, it probably hasn't crashed. Just go grab coffee and check back in a bit. You should eventually be greeted by a timeline full of baked orange keyframes. Delete the copy transform constraint now that it's done its job, and now simply choose Export Alembic. Enable the Settings pane and choose Selected Objects Only. And don't miss this step, or you'll end up with an enormous file as it tries to re-export the cracked Earth simulation. Click Export Alembic and let her rip. When it finishes, you'll have the camera and final rendered images ready to be composited in Nuke. And that's exactly what we'll do in Part 2, the conclusion of Land Sharks.